Now, related to what we were talking about before, you might have heard me say the words absolute value. And so absolute value does mean like just the value of the number itself without the sign. Or another way you can think of it as the absolute value is the distance of any number from 0. So the number 2, for example, is 2 away. Like they kind of drew that in blue, so it's kind of hard to see, but like that literal distance is 2. Well, that's also the case for -2. -2, the literal distance from 0 is 2. So that's why we say the absolute value of 2 and -2 is the same. And the way they indicate that in math is they use these like two straight lines like this. If you see these just two straight lines, instead of parentheses, they put two straight lines. They're just telling you take away the sign, basically. Take away that sign. Now, where this becomes like a little bit complicated is when they put this around a whole thing with like a variable in it, all right? And so that makes life a little bit harder. Now, this is not algebra class, so you will have to deal with this in algebra, how would you solve for D if you had something on the other side. But for our purposes, for number sense, what they're generally going to do is just make you plug something in for this variable. Like, for example, if they say, okay, D equals 1, well, you just plug that in, and you have 2 times 1 is 2, plus 6, 2 plus 6 is 8, and it's positive. And okay, not too complicated. Well, Alejandro, because this is just their way of saying these words, absolute value. It's like the math vocabulary for that, I guess. Just like this, like what about a random dash makes something negative, right? It's just a symbol. It's kind of how they're symbolizing it. So if you see that, you want to just memorize. I mean, there's no good reason for it. It's just somebody made it up. Probably, I don't know, someone did like in ancient Babylon or something, made that up. And it just means the distance from 0. So because -2 is literally 2 away from 0, we just replace that absolute value with that. All right. Now the part where y'all got to be careful about this. Of course, Alejandro. Everybody, please, Alexandros, sorry. Please tell me. Oh, by the way, also tell me if I'm mispronouncing anybody's name. I do tend to do that. I make the best effort I can not to, but please let me know if I am. I've been called Stefan enough times in my life that I know what it's like to have your name mispronounced. So I do want to make sure I'm pronouncing everybody's name correctly. But let's say, y'all, that they pick a different number for D. Let's say they pick -4. And now you're like, okay, well, dang, 2 times -4 is going to be -8. A positive times a negative will be negative. And y'all, this is where also the number line can help a little bit. If I'm at -8, okay, I'm way back here at -8, way down here at -8, and I add 6 to it, y'all, what am I going to be at? -8 plus 6 is going to get me to what? Yeah, it's going to get me to -2, right? So like this is where like I kind of visualize it on the number line sometimes. I have -8, and I'm going to like add 6 to it. Well, it's going to go up, but it's only going to make it to -2. Right, if we add that 6 to it. So that's going to be absolute value of -2. And now, as Alexandros asked, well, if it's absolute value, now at the very last step, we'll go ahead and just take that sign away. We'll just go ahead and throw that away. All right. Shalyn, I'm not sure the answer to your question. If you can put that in the Q&A, down in the bottom Zoom menu. I should also say this for all the new people. There is this thing called Q&A in the bottom Zoom menu. I think it's got like a little question mark symbol on the icon. But if you click on that, you can chat directly with teacher Melissa, and she can help you out. Alexandra, yes, but we cannot really do it here at this point because we don't know whether this thing is going to be positive or negative. So like there's no like negative sign. But once we do know what D is and we do the math, then at the very last step, they are just asking you to take the sign away. They're just asking you to take it away. Okay. Now, why though? I mean, this is a very mysterious thing. Why would mathematicians even create this weird symbol of the absolute value? It feels like completely bizarre. Like, in the world would they do this? Well, there's like a bunch of different reasons in math. The one I'm going to talk about, though, is the nice thing about absolute value is it can tell you the distance between any two numbers. If you want to know how far apart two numbers are from each other, then we can use absolute value to help us do that. Now, like, for example, so they're going to give me this example. What is the distance between 3 and -2? Now, if you look at this, you could just go, well, I can look at it on a number line, and I can go, okay, 1, 2, 3, 4, 5. So the distance between these two numbers has got to be 5. I can just look at it. I can see it, right? But if the numbers are like more annoying like this, it might be harder to kind of like just think through it. So what you can do instead is you can take the difference. Now, pretty much always if you subtract the smaller one from the bigger one, it'll always work out fine. You don't have to use the absolute value on it because if you subtract a negative, that just turns into plus. So 3 plus 2 equals 5, and then we take the absolute value, and it's fine. So if you ever want to be totally safe, just subtract the smaller from the bigger. But the reason why absolute value is at least kind of cool is it sort of doesn't matter what order you do the subtraction in as long as you're taking the absolute value. So notice if I switched it and did -2 minus 3, well, this will work just as well to tell me that distance. It'll give me the negative version of it, but because I'm using absolute value, it will just give me the correct distance. So absolute value is nice for finding the distance between two different numbers because you don't even have to worry about what order you do the subtraction in. Once you take the absolute value, it's going to give you what you want. So what's funny is, let's look at an example of this. And honestly, y'all, I'm going to do this the rest of the way out. One thing that's really important when you're taking the GED, though, is to look at a problem before you just start crunching a bunch of math. Look at your answer choices as well. Because there's a lot of times where they're just not going to make you crunch the math. Like, if you look at these answer choices, they're like, nah, just don't even do it. Just don't even do the math. We just want to set up the math for this one. Okay? Roger, that's what I'm saying. It doesn't matter. Oh, Alexandros might not have heard me, Nyla. If especially if you're brand new, y'all don't throw answers into the chat. I'm gonna open up the poll right now. Now y'all can decide if you want to believe what Alexandros just said right there. But I will always put up the poll. So don't shout out answers into the chat, but you can always put them into the poll. Okay. So Roger, what I was saying is it doesn't matter what order we do the subtraction in as long as we use the absolute value. That's kind of the beauty of absolute value. Does that make sense? Yeah, Alexandros, no worries. Like I said, I figured, people are going to mess up and they might not even have heard me when I said it earlier. So it's totally fine. Okay, but if we want the distance between A and B, well, what we were just saying was we're just going to subtract them. We're just going to subtract them and take the absolute value. And the funny thing is it does not matter what order I do the subtraction. I think most of us would do, 7/8 minus 1/4. Because 7/8 is clearly bigger. This A is clearly the bigger one, so I'm going to subtract the smaller one. And that would be right. That would be correct. That would give me the distance. It is sadly not an answer choice. It is not an answer choice. They did not put that anywhere. So this would rule. I would pick it right away if they gave it to me. That's why we're going to bring absolute value into this, y'all. Because if we bring absolute value into this, now it does not matter what order we do the subtraction, as long as we put the absolute value bars around it. Okay. Now we're going to do this math so I can show you why. It'll also give us practice with adding and subtracting fractions. But y'all, give me a letter Y in chat if this makes sense. Either of these answers would be correct. We don't have to put the absolute value on the top one, but we definitely can. Either of these would be correct, but the only one that we get is answer choice C here. For that, so that is going to be our right answer. Now, let's actually do this math, y'all. Let's actually do it. Let's do the math. Y'all, in order to add or subtract fractions, what do I need? What do I need in order to add or subtract fractions? Brandon, I need that least common multiple. Eddie, I need that common denominator, right? Honestly, that's the main thing I need is the common denominator. I need them to have the same denominators. Mainly because the denominator tells me the size of the slice that the fraction is taking of the whole. It could be any common denominator, but we prefer, as Brandon's pointing out, the least common denominator. So y'all, I want to turn this quarter into eighths. I want to say 1/4 is the same as how many eighths? And y'all, can anybody tell me 1/4 is equal to how many eighths? Yeah, nice. Javin, Alexandros, Debbie, that would be 2/8. Let me give you a couple ways to think about it. One way to think about it is you can always multiply the top and bottom of a fraction by anything you want. So if you want to multiply the top and bottom by 2, that's totally fine. You can absolutely do that. It's not going to change the value of it. Javin, thank you. Like I said, correct me if I'm wrong, because I hate being called Stefan. And so I want to definitely correct me. Do not hesitate. But another way to think about it, y'all, again, I'm very visual. I like to think of fractions visually. So like, let's say I have a candy bar. Oh, and is it Kaya? You know, my instinct was Kaya, not like the car. Kaya. Yeah, that's so funny. It's like, well, one thing that's okay, I'm gonna share a little personal thing here. My wife's name is this. I just go Owl, Sage Owl, Sagel, Sagel. But people, she never gets called. Debbie, no, it's okay. That's so funny because to me it just like is so like exactly how I read it. But I'm also married to the woman, so it might just be years and years and years. It is a nice name, right? It's really cool. But okay, so we're talking about quarters. Let's say I have a candy bar and I break it up into quarters like this, right? And so 1/4 would just be like this piece, right? Right here. Okay? But now let's think I take the same candy bar and I break it up into eighths. Well, in that case, 1, 2, 3, 4, 5, 6, 7, 8. Right now it's in eighths. And hopefully now y'all can see how, yeah, 1/4 is just the same thing as having 2/8. So y'all give me a line in chat if you can see that now with my red candy bar. I don't know why it's red. I should have made it like a different color there. But yeah, so that's the idea. And like whenever you multiply or divide the top of and bottom of a fraction by the same number, you're just breaking it up. I like to think of it as like I'm just breaking it up into smaller pieces. Instead of fourths, I'm breaking it up into eighths now by cutting it in half. And that means I'll have 2/8. Okay, so now if I take 2/8 minus 7/8, well, this is going to throw me into the negative end, right? Because 7/8 is bigger than 2/8. So y'all, if we actually do that subtraction of 2/8 minus 7/8, what is that going to be? Yeah, it's going to be 5/8. It's going to be 5/8, but is it going to be positive or negative, y'all? Exactly, Debbie, Peter, Olivine. It's going to be negative because 7/8 is bigger. So, like, I'm just hanging out at, 2/8 right here, and I'm going to take 7/8 away from it. It's definitely going to put me down into the negative zone. Right. So everybody give me a Y in chat if that makes sense. And that is kind of how I see it in my brain. It's like, I'm at 4/8 and I'm gonna, or I'm at 2/8. Sorry, I'm gonna take all this away. Goodness, it's gonna be negative 5/8. Yeah. But that's why we put the absolute value sign around it, because we do absolute value. And it just turns it into positive 5/8. And let's count it. Let's see if that truly works. And that truly is the distance between A and B. So I'm just going to count it out. Each of these are eighths. So here's 1/8, 2/8, 3/8, 4/8, 5/8. Yeah, 5 of these little eighth pieces in between them. And that is absolutely correct. And we got it. And that's the reason why, for example, this doesn't work, because this would give us a negative 5/8. Now we know, okay, I take the absolute value of it. It's fine, but they don't put the absolute value symbols. We can't add them because, y'all, if we add 2/8 plus 7/8, well, then how many eighths do we have in that case? Yeah, we're going to have 9/8, which, turning that into a mixed fraction, would just be the same as 1 plus 1/8. So that would be like a lot. That would be like all this distance from 0 to 1 and then 1 additional eighth there. So that would be way too big. It's not giving us the distance. It's actually just adding them together, just combines them instead of finding the distance in between them. All right, very good, y'all. Let's do some more. Okay, this is going to be more about just visualizing. And one thing I like to do with these is I do kind of like to draw them as I go, because I'm like so visual. I really like to like draw this stuff as I'm reading. They're talking about directions and like stuff like that. Yeah. So Bob has errands to run. Oh, Lee, I don't know what you mean by cancel the bottom out. Um, the only time when things cancel is when there's a common factor. And we're actually going to talk about factors in just a moment. So actually, why don't you hold on to that question? Because factors are coming up next, and they are very much related to fractions. You're a poor art. Well, Debbie, luckily we do not have to be like a very good artist for these sort of things. I'm not a very good artist either. I will say, like, the one thing when I was a kid I learned how to draw was Garfield. I don't know if I can still do it, but he just has like a nose like this, and then like you kind of have Garfield. Y'all can kind of see it, right? It's not bad. And he has ears kind of like this. Okay, anyway. Taking me back to childhood. But we don't need to be artists. We just need to keep track of directions. All right. So he's gonna walk 5 blocks east. Let's put his home right here. I'm just gonna call it H for home. And he's gonna walk 5 in this direction to the barber shop. Okay, then he's gonna walk 6 west. Oh, that's interesting. So just kind of out of interest, y'all, the way you want to think about it now is, how far from his home is he after he does this? This isn't what the question is asking, but it's the reason why sometimes I draw these to help me keep track. Yeah, he's just one away. He's just one block away from home. He like passed home, said hi, family, and then kept walking to go to the grocery store. Oh, because he needs some food. Oh, then he's gonna walk another 2 blocks west to the post office. Okay, so 2 more blocks. And now how many blocks from home is he? See, I would have passed the grocery store and gone back, hit the grocery store on the way back home. Because I don't know what Bob's doing. Bob's like going to carry all his groceries to the post office and then walk back home. That seems really silly. That seems really strange. But yeah, y'all are right. He is 3 away from home. So he is going to walk back home and go 3 blocks back home. Okay, but what are they asking us? Assuming that Bob's apartment, barbershop, the grocery store, and the post office are all located on the same street, and that's a walkable city right there. How many blocks did Bob walk total? Yeah, Miguel, good. So, like, I kind of anticipated they might have asked us, like, how far from home was he? Because that could be something they asked us. But they're just asking us to add how far my boy walked the whole way. So let's go ahead and add them together. Now, I'm going to bring up something else real quick. How many of y'all, when doing this, well, you might reach for a calculator, but how many of y'all would just go, okay, like 5 plus 6 is 11, and then like 11 plus 2 is going to be 13, and then 13 plus 2 is going to be 16? Yeah, and here's the thing, you can totally do that. But I want to give you all power. I want to give you the power to know that you don't have to do addition subtraction in any particular order. I want to give you all the power to do addition subtraction in any order you want. As long as you're following your signs, watching your signs, you can do that. So what I would do is I would say, oh wait, this is just 5. So 5 plus 6 plus 5. And then I would go, oh wait, this is just 10. So this is just 10 plus 6. Y'all give me a Y in chat if that makes sense. When I looked at these 4 numbers, I want to do the addition in the easiest way. I want to do like the easy addition. I just want to make it as easy as physically possible. So I just look for things that are easy to add together right away first and just do that addition first. Now you do have to be careful if they put subtraction in it as well. You can still do it in what order you want to do it in, but you do have to make sure that like the negative ones you're always treating as negative. Positive ones you're always treating as positive. So, all right, with that little trick in mind, let's try that for this question.